In an ever-evolving digital landscape, for your business to thrive, you must adapt or die. Welcome to Marketing in the Age of AI, the podcast helping you harness the power of AI and marketing tools to revitalize and grow your business. And now here's your host, marketing expert and author of Authentic Marketing in the Age of AI, Emanuel Rose.
Welcome to this episode of Marketing in the Age of AI. Today, we're going to have an inferential walk that is on the outskirts of marketing, but still important to us. Can you imagine a future where digital AI models and biocomputing organoids form a hybrid cognition loop, each compensating for the other's weaknesses? What might such a system be able to do that neither alone can achieve? Well, today I'm joined by Dr. Ewelina Kurtys, a scientist-turned-entrepreneur with a PhD in neuroscience and over 20 peer-reviewed publications. After a successful career in academia, she transitioned into business development and technology commercialization, advising innovative tech companies. And today we'll be exploring on how her scientific background intersects with entrepreneurship, the future of AI, biocomputing, and marketing. Welcome to the show, Dr. Kurtys.
Hello, happy to be here.
It's really nice to have this conversation with you. I really have to know what first drew you into the world of biocomputing, and how did that path eventually lead you to Final Spark's neural platform?
So I did my research in neuroscience, as you mentioned, because I was always fascinated with the human brain. And after, when I started to work in industry, I discovered the world of artificial intelligence, and I realized how many possibilities it can bring. I became fascinated by this. So I studied a little bit about AI. I started to work on commercial applications of artificial intelligence. And later, at one of I was also, of course, going to many events, conferences. I was at the time in London, which was a perfect place to learn about AI, also from the events. And I met the founders of Final Spark at one of the conferences in London. And I became also fascinated with this project because it's a combination of neuroscience, what I know from academia, and engineering, what I know from industry. So this is really perfect combination for me.
I love it. Well, just if we step back one step back, and we say, can you help us understand what biocomputing is?
So biocomputing is a combination of neuroscience and computing. So we try to make computation on living neurons, on real living neurons, the same as we have in our brains. And it's a normal thing to culture neurons in vitro on the dish in the laboratory. But usually it's done. This is done for biomedical research, for drug development, for example. And we use the same methods of culturing living neurons, but for different purpose. Because our purpose is to build computer, so that we can send some signals, some input into neurons, and we want to receive also output, the answer, and we want that this will make sense, like in the computer today we have. Everyone else of us is using.
So it sounds a little fantastical to those of us who are not in that space. So can you give me a 10,000 foot view of how that actually works compared to a solid state chip?
So actually, it works in a way that we have living neurons in the form of 3D structures. We use such a little blob of cells. They consist of around 10,000 neurons each, and they have around 0.5 millimeter diameter. And we put them on the electrodes. So that in this way, we can send them electrical signals, and we can also measure the response. Also on our website, on the finalspark.com, you can see the section live, and you can see this in real time, how we measure the signals from neurons. And also in our brain, in nature, neurons are communicating in two ways, through electrical signals and through chemical signals. Actually, at the end, it's all chemical because also the electricity changes is also due to some chemicals changing on the membrane. So, but basically, we in the lab, we can measure electricity coming from the neurons, and we can send them also electrical signals, and we can also send some substances, chemical, such as neurotransmitters. For example, we use dopamine in our lab, and this can also change. These are things to stimulate neurons, and our objective is to change their behavior so that we can program them. So, for example, we send them some input, and they will learn how to make output, similar way as GPUs and CPUs.
So is there a storage unit like random access memory or a hard drive? How does that?
This is also a good question. One of the big difference between living neurons and digital hardware is that in living neurons, memory and processing is the same. It's in the same space. So that's
Okay.
also a big save of energy, but everything in nature is very efficient, of course. So so this is actually processing and storage. However, of course, when we look at the human brain, we can have idea that brain is not really like super with super huge memory. The biggest advantage of the brain is efficient processing of information, especially complex one. So but the storage and the processing is in the same space in neurons. And actually, how maybe I mentioned this also because it's important. Neurons are plastic, we call it, and also our brain is plastic. So when we learn, the connections between the neurons are changing. So our brain rewires. And also it's the same what we want to achieve in the lab is learning. So we want store and process some information. So that means also that neurons, the connections between neurons will also be rewired.
Right. Yes. This brain plasticity. Right. That's how I understand it from psychology. Right. So we're building neural pathways between the neurons.
Absolutely. And in psychology, we look at the results, which is our behavior, which can change. But at the heart is the same thing, that the connections between the neurons are changing.
All right. So the ultimate vision would be that we're going to have will my laptop be running on biocomputing, or is it going to have to be plugged in by Amazon Web Services in order for me to access that?
Well, actually, we believe in the, let's say, second option much more, because neurons are very fragile, and it's very difficult actually to give them optimal condition in the artificial world. So it's always a challenge. So that's why we think it makes more sense to build a central laboratory. As today, actually, we have a lab for R&D, and we want that this central lab will be available remotely. Actually, today our lab is also available remotely, but for research. But in the future, we want that it will be kind of like bioserver, so that it will be available remotely. Like today, you can connect to cloud computing, and remotely you can get cheap computational power, because that's important to say. That's the whole point of doing this, is because neurons are 1 million times more energy efficient.
1 million.
So the difference for the user, hopefully, will be that, no difference for the using the software, but it will be just much cheaper. So, for example, we will be able to run LLMs using 1 million times less energy.
Which is a significant instance, because just today we saw a big nuclear power plant deal being signed between the US and the UK, right?
Absolutely. Because actually there are two ways, to solve the current kind of crisis for the energy which is needed for AI. So either alternative energy sources or alternative computing. So we work on the second.
Okay, so it's a beautiful vision in terms of saving energy, so we can continue to develop these AI tools to make our lives simpler. If let's just say we're on the 100-yard dash, where is Final Spark in terms of being able to access it by AWS to run my AI software for my marketing campaigns?
So we are in an early stage. So far, we were able to store 1 bit of information in our neurons. So this is very little. So this is very beginning. We are also currently self-funded. So we are a small team of 6 people. Everything is going slowly. But we expect that we are also talking to investors. We are seeking 50 million Swiss francs, which is around $50 million. And we expect that with this money, we can accelerate our research. So we expect that once we accept the investors, we will be able to build a biocomputer, bioserver within 10 years. That's the
Okay.
idea.
So, yeah. Wow. That's interesting. So I guess where is it? Is it a space, or is it? Where's the money going to go in order to develop the biocomputing?
Well,
What's the plan?
mainly into the people, and because that's the biggest challenge always. I think the progress of technology depends on how many people are working on this, and that's the most important. So we will have to increase the team, and the rest of stuff is not so much, let's say, expensive. Paradoxically, having the lab is not the biggest expense, but the biggest
Yeah.
is the people. We need very specialized people, very multidisciplinary team, and
Yeah.
that's of course always expensive.
Sure. Still need the human brains, right?
Mhm. Yes,
Uh,
yes, absolutely. Real brains to work on that. Yes.
well, let's see. So, what's the source material for this biocomputing?
So we use human neurons, and why it's possible is because today we have methods that we can get stem cells from human skin, and from
Okay.
the stem cells we can get theoretically any type of cells we want, including neurons. So that's the way. And actually, this is also very great scalability because we can get huge amounts of neurons in this way.
Yeah. And so, are some of your skin cells in there in the computer right now?
Sorry, what?
Some of your skin cells
No, no, no,
part of the
no.
project? No.
Actually, this is a bit well. Actually, funny because it's commercially available, so you can just buy stem cells from human
Oh,
skin.
okay.
Also, for us, it would be rather dangerous because you should not work with your own cells. This is because in case they would get to your body, then your body would not recognize them as stranger cells because they would have exactly the same DNA, and
Yep.
that could cause problems. So working with your own cells in the lab is not a good idea.
Okay. I'll keep that in
Especially that we
mind.
want to play with viruses at some point. We don't do
Yep.
this yet, but then it would be even more dangerous. That would be very, very bad. But you
Understood.
can just buy them.
I
Yeah, it
understood.
solves a lot
Okay.
of problems also because some of the process is already solved, so we don't have to worry about this.
Interesting. And how about besides the ethical part about not working on your own skin cells, what are the other ethical situations that you're running into with biocomputing?
So actually, we get some questions from the general public for the reason because I think this kind of project is stimulating human imagination. So of course, people have
Sure.
questions, and some of them have questions related to ethics. Some people ask if it's okay to use living neurons, and what is the border between organism and human. So these are important questions. So that's why we reach out. We put a lot of effort to reach out to philosophers to encourage them to work on this kind of topics, which is, I think, interesting because
Yes.
it's a new field. So it's
Right.
bringing new questions, and we are absolutely not really competent to answer them. Of course, ethical side. So we hope philosophers can help us.
I like that. You're going to stay in your domain, the scientific part, right?
Yes, absolutely.
Okay, fair enough. How about that fear that AI gets together with the biocomputing and it creates some kind of a humanoid with an AI brain? Is there any viability to that?
I think it doesn't really matter because the general biggest threat currently on AI is that it can become smarter than us, and in this case, we have to make sure that it will not go against us. But this really doesn't matter if it's a biocomputer or a digital, because it's all about the level of intelligence, and that's really the most important. So I would say this problem is general, not only for biocomputing, but for any type of computing, especially when it becomes very intelligent, that we have to make sure that they have right value function and that they follow our values, which I heard is very difficult. Some experts are scared that AI can turn against us one day.
Yeah, again, it's some things that we have to work out moving ahead.
Yes.
So the positive side though is the power consumption is much less than physical chips.
Yes.
How about the speed compared to physical chips?
No, the speed we shouldn't expect a lot. Actually, that's why biocomputing would be good for tasks where speed is not crucial.
Uh, that's interesting. And then and memory per space is similar, or is that why you would have the big labs for the memory?
Well, this is hard to say at this moment. It doesn't really matter because we do fundamental research on very little pieces of structures. But in the future, we would like to build huge structures of neurons. It's hard to predict how much memory they will have, because when you build maybe 100 meters of neuronal structure, then you can have something interesting. But generally, I would say digital computers have enormous memory, and probably that will not be the biggest advantage of biocomputer.
Interesting. Okay. Well, what else? What questions should I have asked you that I haven't yet about biocomputing?
I don't know how many users we have, because our lab
Yeah. Oh, yeah.
is
Okay.
available remotely, which is a very interesting thing.
Yeah.
Because during COVID, our scientists, they wanted to keep on doing experiments, so they had to develop stuff for working remotely. So today you can access our lab through the internet browser. You can write code in Python, and this will be, you can do everything with that. You can run the experiments, collect data, analyze everything. So many people work with us and they have never been in our lab. So that's interesting. And we have 10 universities from all over the world working with us. And we also have first commercial clients, which is very interesting thing. This technology doesn't work yet, but it's similar like with quantum computing. We have also companies which are making money already with quantum, although it's not working, but people want to know the basics, how it feels. Even if it doesn't fully work, people just want to play with this. So similar with biocomputing, people pay us to get access to the lab and to try to program living neurons. So these are more fundamental researches in signal processing of neurons, but we are very proud that we have already such an interest that even we have commercial clients.
Yeah, that's amazing. And so you can work with neurons remotely wherever you are with some test projects. That's awesome.
Yes, and this is fantastic. Yes.
What project are you working on right now on the computing side? If you can translate it into marketing parlance for us.
No, I work on the commercial side. So since I left academia, I discovered that I love to talk to people, and I love to business development and sales and marketing. So I do actually everything commercial.
Nice.
It's a small startup, so we have a variety of problems. We talk to investors, we talk to collaborators, we have clients, so all these things. We also talk with press or with podcasters, as I talk with you today. So that's what I do. So I don't work on any specific issue, although I take part in some discussions in R&D. I left the lab. I don't miss it, but still I sometimes enjoy to take part in some discussions on how we can approach some of the experiments. So that's also, it's always fun.
That's good. That's good to know what you love, and you obviously have the background to talk about this in depth with anybody. I'm curious, which of the LLMs do you use for your daily work, if any?
Absolutely, I think it would be dangerous not to use LLMs. So I personally use ChatGPT, also Final Spark. We actually don't experiment too much with other models. Although I heard some opinions that some of them are better for coding, other for other tasks. But I'm using ChatGPT. I have also subscription. So yes, so that's my friend. Yes.
Okay, fair enough. I have a question from LinkedIn about will the scaling problem be maintaining the neurons or increasing the processing, or both?
I think that increasing processing, I'm not sure we have this problem, because now we're just trying to learn how to program neurons. So once it works, I think it would be just a limit of nature, how fast they can process. maybe we can increase the size so we can process more at one time. But this we have to see. But for sure, the maintaining neurons is already a big challenge, because it's very difficult to keep neurons alive in the lab. We know from nature they can live up to even 100 years because they live in our brains.
Right.
Actually, almost all our neurons are always the same, because they don't really proliferate that much. Only in some regions you have new neurons, but most of the neurons you get, you stay with them all your life. So they can live long, but in the lab it's very difficult to keep them for such a long time. So that's a challenge. For now, we can keep them alive on the electrodes for 3 months, which is actually really good. Like for the industry standard, is really long.
Interesting. And so then are you able to then download that information from neuron to neuron, or do you have to start from the beginning?
No, so far we were able to store 1 bit of information, so
Right.
very little.
Yeah.
So now it doesn't matter, but yes, absolutely. In the future, we hope we will be able to do this, that we can take, if one neuron will, let's say bunch of neuron will die, we can transfer everything to another one.
Right. Yeah. That's fascinating. Well, I really appreciate your time. Thanks for spending this time with conversation.
Thank you
Dr.
too.
Kurtys.
It was really a pleasure.
And we'll make sure we get your information for Final Spark and your LinkedIn connection.
Yes.
Is that the best way for people to connect with you?
Yes, it's always perfect. Okay. Yes, it's a good way.
Okay. Well, thank you so much, and
Thank you too.
I look forward to having you on again in a year and see where you've gotten.
Thank you.
Okay. Have a great night. Well, what an amazing change that we will hopefully see in the next 10 years or shorter. The idea that we could use biocomputing to decrease the power consumption for all the software that we're writing and its computational power is a phenomenal opportunity. And I'm sure interested to see how things develop and to hear what the philosophers say on the ethics of all this. I hope you've enjoyed this episode. Thanks for joining me. And I also hope that you take some time today to find some places in your workflow that AI can take over some of the mundane tasks of your work. And that with that time that you get back, that you spend it upskilling, that you spend it with your friends and family, or that you get away from the screens and get outside in nature. It's Emanuel Rose, Marketing in the Age of AI.
Thanks for listening to Marketing in the Age of AI. Be sure to subscribe wherever you heard this podcast so you never miss a future episode. Your copy of Authentic Marketing in the Age of AI is available at Amazon.com or EmanuelRose.com. You can also connect with Emanuel on LinkedIn. Thanks again for listening, and we'll see you next time.